Thank you. Thank you very much for having this paper in the program, Philippe Aghion and Patricia. So it's not going to be, unfortunately, about movies or fashion, but hopefully still something interesting. So we are going to talk about public spillover from public to the private sectors. It's a joint work with Arthur, Emeric, and Clément. And the motivation for this paper is probably very straightforward for this audience, but we all know that innovation, and especially the innovation that is the research that is done in public universities, creating some kind of positive externality to the private sector. We have recent evidence with the COVID-19 vaccine. The Oxford AstraZeneca vaccine was essentially financed through university. And in the US, the NIH was also responsible for a lot of the financing that went through the development of the vaccines. More generally, there is a lot of stories about the role of the US DARPA in subsidizing and being at the root of some technologies that are very iconic as private sector's products, such as the iPhone. So we have a lot of evidence, and we have a lot of anecdotal evidence, but actually measuring those spillovers, so the spillover from public laboratories to private firms, is kind of challenging empirically. The reason is that there's no obvious paper trail. It's not very easy to follow the money because the primary goal of university is not to create knowledge that they're going to sell to the private sector, so we cannot really follow the money. And also those funding are generally not targeted to specific technologies, so it's hard to relate one technology to the public entities or the laboratory that produced the knowledge that was at the root of it. There is a great paper by Pierre that is actually looking at this question, looking patents and patents that actually cite paper that has been funded through some specific grant. But usually those kind of evidence are kind of scarce, especially in a country such as France, where universities are not producing a lot of patents, and there are very few links that you can use between the public and the private sectors. And this is the reason why there is little causal evidence on spillover from public research to private R&D, and there's even less causal evidence on the channels through which, if any, those spillovers occur. Okay? And this is, of course, an important question for the design of public policy and innovation policy more generally, and also to firm strategies. So this is what we are after in this paper, and in fact, what we are going to do here is to evaluate a large-scale funding program that was started in France in 2010 as part of the recovery plan following the great financial crisis, which is called the LabEx. I'm going to come back exactly to what this is about. But our idea is actually to propose a new measure of technological proximity between public research labs and private firms. And our idea is to assign a scientific position to industry. So what the literature typically tries to do is to use the only source of information that you can find from university about what type of technology they are producing, using patent data whose assignees are universities. So this is, of course, very useful because you know that then when you know patent, you can look at citation link between patent and you can really track the spillovers. And in that sense, the idea of those papers is to assign a technological position to university or to public labs. And we are going to do exactly the other way. What we're going to do is to take every industry and look at the type of science that they are likely to use as an input to their production function of their technology. Then with this measure, we're going to evaluate this large-scale program that I mentioned. It's called the LabEx, for Laboratory of Excellence. So basically, the LabEx program was allocating 1.5 billion euros across 171 research clusters. So research clusters are like laboratories, can be a bit bigger than one laboratory, but it has to be researchers working in the same place on topics that are very connected. And our evaluation of this program is going to exploit variation in the exposure of the shock, both across sectors and across geography. And the third thing that we are doing is that we are going to bring together a lot of data to try to look at the channels more directly. So do we think that the spillovers occur through the contracting channels, the labor flows of workers between university and private firms? Or is it just, just a casual discussion between researchers and engineers, this is something that we will be trying to look into. Very briefly, our findings. So our new measure of technological proximity, we show that it makes sense as much as we can say, in the sense that it correlates with other information that we have on direct links between universities and firms. We show that there is a causal impact of public research on R&D effort in the private sectors. We find that there is substantial spillover, and to give you an idea of the magnitude, we found that this program, so firms that are more exposed, whatever this means, I will describe more clearly, but firms that are in the top quartile of exposure of this program increase their R&D wage bill, which is our main measure of the input of R&D in the private sectors, by 20% compared to firms that are not directly impacted by this program. Okay, so it's a big effect, especially if you compare it to the main R&D subsidy program that we have in France, which is the R&D tax credit, and whose effect on R&D is not very clear, and the evaluation that we know do not really report sizable effect of R&D on R&D, and they are much more costly than this one-off 1.5 billion euro expense. We also found some effect on R&D output, essentially on plan creation, and some mixed effect on patenting that I'm going to show more in detail. In terms of the evidence that we have on channels, we found that the contracting channel is particularly important compared to the other channels that we can investigate. So the effect is essentially coming through the fact that know that the laboratory have more money, they can buy also more time, and they're able to collaborate more directly with private sectors by taking some R&D project as a contract instead of the firms. Okay, so they subcontract some R&D program from firms. Okay, so the literature, the main paper that we relate to is a paper by Pierre, who is, hopefully I'm not wrong, who is looking at how the NIH program helped generate some development of new technology in the pharmaceutical sectors. And in fact, our idea initially was to replicate this approach in the full set of industries and technologies that are impacted by the LabX program. The issue we had is that we don't have a lot of links. Okay, so to replicate this, to implement this method, you need to take papers to look at which grant those papers used, and to look at the patents that are citing this paper, and then to develop everything you can do with the patent data. This could work in pharmaceutical sectors. It could work in very productive laboratories such as the MIT or laboratories that are producing a lot of papers and even a lot of patents. But we are going to look at a very general program that will be targeting laboratories that are doing engineering, biology, even economics, got some LabX. So it's, we need some kind of approach that is a bit more general that we can implement here. Okay, so the LabX program, what it's about. So in 2009, so again, as part of the recovery plan, the government launched 1.5 billion euro dedicated to public research. There were 400 candidates, so the candidates were laboratories, public laboratories, and 171 were selected. They cover really any topics that are studied in university, and there were some kind of effort to make sure that the program will finance the full variety of topics. So you have literature, human sciences, and also physics, engineering, pharmaceutical. Obviously, we are going to look at the spillovers using, spillover in terms of R&D, so it's mostly going to be about the third category, the STEMs category, let's say. But the program was, aimed at financing everything. So how were those 171 clusters selected? So it was made by an international jury of academics, and those jury were asked to grade each proposal out of 7 dimensions. And the dimension that was the most significant was, of course, the academic excellence of the laboratory. Okay, so those international jury, they are academic from Germany, Netherlands, other countries in Europe, essentially. They don't really have any, incentive to subsidize some specific industry. And really what they will do is to select the best program in terms of the academic content. And this is going to be important for our identification. I'm going to get back to this. We got information on the grades that were given by the jury. So the 7 grades for each program, even those that have been rejected. we got access to the proposals, and especially the bibliography of the proposals, the amount that they requested, and in case they got financed, the amount that they got, which could be slightly different. And we also had access to the launch plans, which are actually plans that the laboratories that were financed had to produce 2 years after the financing to explain exactly how they planned and how they already had spent the money. Then we also have a ton of different administrative data that I'm going to skip describing, but basically we can measure a lot of what's happening on the private sector side in terms of R&D and innovation activity. And from all of this, we are going to construct our proximity measure. So what's the idea? Again, the idea is to be able to say this specific industry is going to, before using everything we know before the program, before 2009, this specific industry is more likely to use this specific science as an input in the development of its technology. And typically, this is the kind of proximity measure that we want to use, because then, based on this proximity with all the kind of science that are produced by different laboratories, firms are going to be more or less exposed to the program. Yeah. So again, we couldn't really use academic patents because there are very few patents, and we also couldn't really use patent to paper, direct patent to paper citation from the laboratory. And the reason is that laboratories are included in broader universities, okay? And usually the researchers are just signing with the name of the university, not the name of the laboratory. So it was impossible for us to retrieve all the papers that's been published specifically by the laboratory that got the funding. So that's an issue for us. So we cannot really, look at the direct link between the private and the public sectors to use this as a measure of the exposure. So what we did is the following: we took the proposals of all the 400 candidates, okay? And from the proposal, we look at the bibliography, and we use a tool that was designed called Groby. It was designed to extract those information that are kind of, unstructured, and to put them in a very structured way. So we have a bibliography list. And then we use Crossref to match each of the paper to the journal in which they were published. Okay? And so the idea of this is that from each LabX, we don't really know what this laboratory is about. We have some broad idea that is doing some math or physics, but we don't know very precisely what it's about. What we know is that in this proposal is going to cite a ton of different papers. Of course, the paper that a member of the laboratory has published, but also papers that are kind of important and pivotal in the type of science that they want to do. And we think that the distribution of journals in which those papers is published as a good measure of the type of science that the laboratory is doing. Okay, so it's like if you are citing a lot of papers that are published in economic history journals, it's very likely that you are doing something related to economic history. Okay, so at the end, for each laboratory, we have a vector of weights that is giving you the probability that you are citing in your proposal a paper published in the corresponding journal. So that's the first part of the proximity measure, and then we need the other side of it, which is from the firm. And here what we do is simply to use patents. Okay, so we take all the firms in a given industry, and we match those firms to the patent, get access to their patent portfolio before 2009, before the program. From the patent, we use a tool called PatSeed that will extract all the paper that has been cited in the patent. Okay, so patent is pretty much like the articles that we write. So they cite each other, but they also cite academic paper. And they have to cite academic paper when they use the content of this paper to produce the technology that is protected by the patent. Okay, so we take all those academic papers that are cited by the patents owned by the firm in Industry J, and then again we match them to the journal in which they are published. Okay, so this time, this vector is giving you the probability that I'm going to use a paper published in this journal as an input to create my patent. Okay, so then we have, yes?
So I guess there's a reason you did this at the industry rather than at the firm level.
No, we could do it at the firm level, but we needed, vector the vector would be too sparse if we do it like that. So we have very few firms with patents, so we thought that aggregating makes more sense. But everything I'm going to say is going to be at the industry level, but we could have done it at the firm level, exactly. Okay, so we have the two vectors, and then the only thing we need to do is to take the dot product of those vectors. Okay, we normalize it so it's between 0 and 1, and basically this is giving you a proximity measure between each laboratory, each industry. Okay, based simply on the fact that the firms in this industry are very likely to use the science produced in this laboratory as an input. Okay, so now that we have our proximity measure, we can aggregate it. So we have some kind of variation, sorry, at the laboratory time sector level. Okay, but the problem is that we can't really measure anything, any outputs at this level of aggregation. So we need to aggregate everything at some level at the geography time sector level. So laboratories, they are spread all over the territory. So there could be 2 laboratories, two LabX in the same city, but they can also be spread in different areas. So what we did is we aggregate everything using our proximity between industry J and laboratory L. Okay, so that's the industry exposure of the program. We multiply it with the geographical exposure, which is simply based on the geographical distance between the laboratory and my firm, okay, where I am. And then I multiply all this by D, which is the amount that the laboratory received. Okay, and I aggregate all this at the commuting zone by industry level. So typically, you will get a very large exposure if you are an industry that is very well connected in terms of the science you are using to this specific laboratory, and that you are located very close to the laboratory. So we took a very simple baseline measure of the geographical exposure, which is simply going to be equal to 1 if you are located in the same commuting zone, département, zone d'emploi, sorry, in French. So there are about 300 commuting zones. And 0 if you're not. Okay, so we have tons of robustness showing different, results, or the result varies with different assumptions on this, but this is the simplest we could came up. Okay, so basically this assumes, the underlying idea is that the spillovers are going to be higher if you're located close to the laboratory, and if you are in an industry close in the technological sense to the laboratory. Okay, so of course there are, many discussion about whether this measure makes sense. So we have 2 different validity exercises. To very briefly describe them to you, we use the CIS, the Consumer Innovation Survey, where here firms are asked about whether they are usually sourcing their information to universities. Okay, and we found that our measure is well correlated with that, and we also find that this changes after 2010. It's a sense that more and more firms report that they are sourcing their knowledge to local universities. We could have used, also other measures of proximity. So as I said, there are many ways we could do it using direct citation of patent to paper or patent to patent. But again, there are a few data points that we could use. We tried different alternatives, and the idea was to try a different way to locating a laboratory this time in the technological space. And well, the idea that we use is to take all the papers that are cited in the bibliography of the proposal again, but this time we look all the patents that directly cite those papers, and we look at the technological classes in which those patents are published. This time we have a measure of the technological position of each laboratory, and we do pretty much the same, and the results are kind of robust. I will show you if you're interested at the end of the talk.
Could you use the funding for humanities as a kind of placebo that we wouldn't expect there to be?
You mean including economics then? Yeah, no, we. So the issue is. Yeah, so the only issue is that we wouldn't be able to measure the proximity very precisely in that case, because for that we need patents that are citing paper published in economic journals, which doesn't happen so often. So technically we could do it, but it's going to be, I haven't tried, but I guess it's going to be extremely noisy. But we have also placebos that I'm using essentially the programs that have been rejected. So we also have information on those, and we can generate those kind of alternative counterfactuals. Okay, so in terms of our identification, so of course the idea is that the shock in funding resulting from this program is going to affect certain commuting zones and not others after 2010. And within those commuting zones, some industry more than others. Okay, What we're going to do is to identify our effect within a commuting zone, okay? And we want to look at the variation in the exposure across industry within a given commuting zone. And essentially, our main regression is going to look like this one. So this is the static version, the simplest way we could find. Y is a measure of R&D, let's say R&D expenditure. Beta is going to show the effect after 2010 of increasing the exposure by 1%, essentially. And we add fixed effects that are at the commuting zone industry, and then commuting zone year. So again, essentially, we are looking at variation within commuting zone across industries. So this is our main, static regression. We also report the dynamic equivalence, so we can look at pre-trends. That will be also helping us for the identification.
That doesn't seem to use the amount of subsidy, though, is it?
So it's within the exposure. So the exposure is it's multiplying the proximity with the amount. Okay, the underlying assumption, of course, as usual, absent the reform, we wouldn't see the trend that we observe, so we would observe parallel trends independently of how much you got in terms of exposure. And we can think of two main threats to this identification. The first one is that, of course, the selection of those laboratories, is not random. The jury is going to select the best candidate that they got. So for us, that would be essentially an issue if we think that the proximity, the exposure to those good laboratories is not random, or at least it's not, it's correlated with your future R&D dynamics. Okay, so we have industry, we have commuting zone year fixed effect, and we have industry commuting zone effect. So, it's going to, for this to be a problem for our identification, it would mean that the jury would be selecting program, especially because they think that in the future, the sectors that are more connected to those laboratories are going to be experiencing a boom in technology no matter what. Okay, so that's the main trend that we cannot really control for, although we could, use sector time year fixed effect on top of everything else, but even there you could think that the effect would be local. So that's a potential problem for us. So the first answer we have is that it's, when you know who those jury are, it's very unlikely that they have any private information or even knowledge on which, where are going to be and what are going to be the industry that are going to boom in the future years in terms of technology and R&D. But still, what we can do is to look the grades to address this. So basically what we do is that we restrict the sample to laboratories that are very close in terms of grades. So unfortunately, those grades, they were not binding in the sense that you didn't have to, get, above some grade to get the funding, and below it you didn't get anything. So it's not like there is a clear cutoff that we could use to do some kind of RDD. But still, we found that there is this grade, which is 30 out of 35, which is the best as discriminating between selected and non-selected projects. And what we did is that we selected only the clusters that are around this grades to do some kind of RDD. So that's the first potential issue with our identification. The second one is that it's something we call non-random exposure to random shock. So even if you think that there is no issue with which laboratory are going to be selected from the industry point of view, you can still think that there are some industries that are more connected to science, and no matter what would have been the allocation of the funding, those industries would have reacted positively. Okay, so for example, pharmaceutical, they are using a lot of input from the university. And even if this specific LabX wouldn't have received the money, we'd still expect the pharmaceutical industry to be reacting positively to this kind of R&D policy more generally. So to look into it more precisely, we use a recent paper by Boruchek and Hull, where what they do basically is to develop a placebo test, which aims at randomizing the treatment. So basically, we use the grade, we use clusters of grade, and within each cluster of grade, we randomize completely the treatment. Okay, so we gave the money randomly to laboratories that could, have been rejected, and we calculate our outcome exactly the way we did. Okay, and if you think that the only thing that matters is that some industries are going to be more connected to science, and so more connected to any kind of R&D policy, then you would expect this random allocation to generate positive effect. And so the test is basically to control for those kind of randomized treatments. in domain regression, and we expect those to be non-significant, basically, which is what we did, but I'm going to show you after I show you the main result, which is just here. So this is using R&D expenditures, so it's looking at R&D inputs, okay? So this is using R&D expenditure measured by the wage bill of R&D workers, okay? So this is, of course, not integrating all the kind of R&D expenditures that you could think of, but it's the bulk of it, and the advantage of using this measure is that we observe it very precisely, okay, using simply administrative data. Whether R&D expenditures, there are some questions about whether they are mislabeled, and they are usually declared at the head of the group level, so it's very hard to allocate them very precisely. But I'm still going to show you robustness around this. But if we think of it as a measure of R&D inputs, well, you see that before the treatment, you don't have any significant effect, but then quickly after the treatment, we see that doubling the measure of exposure corresponds to an increase of 1% in R&D wage bill. So what does it mean to double the measure of exposure? Yeah.
So I'm not sure this is the best time to ask this, but just to understand the program a little bit better. So it was 15 billion or 1.5 billion divided among 170 labs.
Yes.
And there were 400 applicants. And so my guess is the ones who didn't get the grants didn't cease to exist, but they continue doing something. And so how should I think about the exposure of firms to the non-winning labs R&D is question number one. Question number two is how significant is this funding compared to the base funding of these labs? So they get on average, I guess, 10 million or slightly less. Is that a huge chunk of money or is that a small chunk of money?
Okay, so on your first question, I'm not sure I have a good answer. So we have constructed some placebos using those rejected programs, and we did as if they got the funding by using the amount they requested, okay, and then we calculated the kind of the exposure that would be generated by this counterfactual world, and we didn't find any effect. We didn't find negative effect, so there is no selection of firms to the best lab. But I'm not sure exactly what we would expect. I guess those laboratories didn't, they continue the business as usual, so we didn't expect anything. And for your second question, so that's not a big funding in the sense that it's, as you say, it's 8 to 10 million, for each laboratory. Those laboratories are not very big, so usually what they did with the money, from anecdotal evidence that we got, is that they bought some time in the sense that the researchers were freed from administrative duties because they hired someone to do most of the work. They could hire more postdocs or more doctorate, PhD, but they didn't really, change completely the way they worked. There is a previous paper by a subset of my co-authors that are looking exactly at the outcome at the laboratory level. And here what they find is that, again, it didn't change completely the way they work, but the quality of the output has increased. And essentially what happened is that people had some time to organize more conferences and to talk more to each other, which is also what you would think, an economic laboratory would probably do if they got some kind of funding. They will do more conferences and they will hire more postdocs. So this is probably what happens in here.
Comparing the 1.5 billion, what is 1% R&D wage bill? Is that going to be
okay, so
150 billion, or what's the?
I have the answer to that, but just in 1 minute, if that's okay. So 1% here doesn't mean anything. I mean, 1% of R&D, that's a lot, of course, because I think the aggregate wage bill of R&D workers is about, the total R&D expenditure is about 23 billion euros, okay? So that would be huge, but we don't really know what doubling the exposure means, right? So this is probably easier to get. This is discretizing the treatment. So what you find is that if you're in the top quartile, you get an increase in 20% in your wage bill, but that's the top quartile of firms that are exposed, okay? And so they will spend 20% more than if they hadn't been exposed. And on the aggregate, what that means is that for €1 of the program, we get 80 cents. That's been an increase in R&D expenditure in the private sector. Okay, but again, the program was aimed at subsidizing only the public research. So that's on top of everything else. That's a local effect, though. So it's not, we haven't really came up with a straightforward way to get to general equilibrium effect. but we have some evidence and that this effect is actually could be taken as the aggregate effect, and the reason is that so we found that this effect on the R&D wage bill is driven 80% by the fact that there are more engineers. Okay, they are working more R&D workers. They are working longer hours, but that means there are more of them. A bit of it is driven by the fact that they are now seeing an increase in their wage. So that's suggestive of the fact that there is an increasing competition for R&D workers. But what we found when we tried to look at where their additional engineers were coming from, we didn't find any effect on the mobility across commuting zone or across sectors. What we find is that it's essentially resulting from more entry, from engineering schools essentially, and from longer tenure. So basically, we observe that most of the time what happens is that R&D workers at some point they move to management, and firms that are more exposed to this program, they will retain R&D worker longer. Okay, so this is why we think there is no much crowding out effect across commuting zone or across sectors, and so the 80 cents for €1 result that we got could maybe be taken as an aggregate measure, although we don't have the proof. So as a robustness, we use a direct measure of R&D expenditure is a bit less precise, but we got to some similar effect. And then moving to the output of R&D, so we do not have a lot of information about R&D output as usual. There is, sorry.
No, I have just a question. Did you have a look at what happened on the research tax credit, crédit impôt recherche, and maybe if you had, some firms which took advantage of it to use the research tax credit, and so that could benefit both from the LabEx and this?
Sure. So we don't. We think that we don't. Of course, we don't observe R&D if firms do not ask for the R&D tax credit, so we wouldn't know exactly. But at this stage, so this is after the big reform of the R&D tax credit in 2008. So we think that the access to the R&D tax credit is becoming very easy for firms. So we think that all firms are asking for the R&D tax credit. But there is some dimension in the R&D tax credit that we are going to use, is the fact that if you outsource one of your R&D projects to a public university, you get an additional tax credit. And this is what we are going to use to identify the outsourcing effect when we're going to talk about the channels. So R&D output, so the first measure that we thought of in terms of R&D output is the creation of new plans. So we think of it as the creation of startups. So it has to be plans in sectors that are, in a sector in a given commuting zone, and that's the static. This is the coefficient beta from earlier. So the static effect of the reform on those firms. So if you're exposed to, the program, we'll experience more new plans, and that's driven purely by new plans from new firms. Okay, so it's not big firms that are moving around their existing plans. It's purely new firms. Then we wanted to look at patents, and on patents we didn't really found.
I suppose any of those new firms are actually academics in the university setting up spin-outs.
Yeah. Exactly. So it's not all of them, obviously, but there will be some of them. So we have a way to identify them, and I'm going to show in a few slides, if that's okay. Just talking briefly about patents, because that's a very recent result that we found. So we couldn't really find a clear effect on the number of patents. We found some kind of very small effect, but it's not extremely robust. But what we find that is much more robust is that the connection to science of the average patent that is filed in those industry commuting zones that are more exposed has increased. Okay, so we measure it using NPL, which is non-patent literature, so how much academic paper I'm citing in a patent. Okay, and we see that the average patent has more and more NPL when they are more exposed to the reform after the reform. We also find some effect on the average quality of the patents that we measure using forward citations, and this is the graph that we had. So this is the average citation to non-patent literature in patent file, again, in those areas that are more treated in industry that are more exposed. And this is the average number of forward citations. So we don't see a clear effect in the number of patents, but as you would expect, industry that are more connected, they are going to be using more and more the academic literature to produce their technology, and as a result, they would produce better patents. Okay, so that's it for the baseline results. We have a lot of robustness, including removing the sectors that we think we could think are driving the effect. Essentially, the pharmaceutical sector is going to capture a big part of this program, but everything is robust, excluding this sector. We also try a bunch of placebos using the grade and using randomization of the treatment that we could do thanks to the fact that we also observe what happened to program that has been rejected. So
Antonin, can you show the thing on geographical spillovers?
you want to check that it's not fake buttons? Okay, this one.
No, the next one.
Oh, sorry, this one. Yeah. So so we did. This is the main thing that we did. So typically in this literature, people use this kind of geometric decay. Okay, so you think that the effect is very strongly concentrated around the laboratory. As you move away, it should be lower. So there's this kind of weight. This is the distance between a firm and the laboratory that we measure using CTs. Okay, and so we use this weight instead of the phi that I presented before. That was 0,1 basically. This is showing you what it looks like. So the only issue is that, of course, there is no actual measure of this exposure, right? So it's not like we can validate any functional form. The only thing we can do is to use existing direct citation and to look at the distance between patents that, between patents that are citing each other, but we can't really validate it. So, this is aggregating the exposure at the geographical level using this kind of more continuous measure of exposure, and the result is this is our baseline, right? And when we use those weights that are using a continuous distance, we still have some positive coefficient. The number are difficult to compare because we are not using exactly the same sample, but they are still significant. There's something else that we did, which is to test directly that there is no crowding out effect. So what we did is that we look at the effect on neighboring commuting zone. So we took the commuting zone in which the laboratory is located, and then we look at the effect on all the commuting zones that are directly touching this commuting zone, and then on the commuting zone that are at 2 degrees, 3 degrees, 4 degrees, etc. And we find that the effect is declining quite quickly, which is I think, disappearing around the average size of the commuting zone, which is about 50 kilometers. So this is why we use this critical distance of 50 kilometers. That's the one that I'm using here.
Is there anything in the design of LabX that might explain why it's so geographically localized?
You mean differently from the general spillovers?
There's been work coming on that. Do you remember the work by is it related to the work that Monica Schnitzer and someone comes to Narila, a new professor. You remember that paper? And there is an action in the firms located nearby.
Across many, there is localization of spillovers, right? But there's still a lot that's not localized.
No, I agree with you. So,
hopefully, if chat publishes something, I can really make use of it at MIT. I like to do that. That's how it's supposed to work. They should strike us as a non-moving net to chat.
So we have tried. I don't have it, but we have tried something where we aggregate everything at the sector level, and so we don't use the geography anymore. And we have an effect. So what you say is true in some. It's true in the aggregate, but the effect is.
Sectoral and not geographical.
Yeah, we did that. So, but the effect is stronger locally, but it exists even if you go very far away.
And if it's really very, very localized, it kind of heightens the concern that the committees who allocated the funds were very much thinking about clusters, basically.
Yeah, exactly. So. Something I haven't mentioned is that, I was about to mention it, but the LabX, they produce like So the jury, they produce a report explaining their decision afterwards, a kind of a referral report of the proposals. And on that, they gave an explicit grade on the potentiality to generate spillovers by laboratory. And what they really emphasize is that they want to generate some kind of positive externality with the what's the name, the local cluster from a different policy that I forgot the name, but basically like a place-based program that existed before the LabEx. Okay? And so what we did is that we took all firms that are participating in those programs and we took them away from the sample. Okay, so what we look is the effect on top of this existing program. But really what we've been doing for quite some time right now is we have read all the proposals. And because initially we were a bit worried that, those laboratories, what they are going to say is that I'm going to collaborate with all the firms that are nearby, you should give me the money because I'm going to help all the local economy. They don't really say this, so they had in the proposal, they were supposed to mention explicitly how they are going to collaborate with the private sectors. And usually what they understood by the private sector is everything that is not a university, but it was essentially like public institutions still, like the OECD for economists or the INSEE. They really, really rarely mention explicitly private firms. And what they do is really like the top 40 firms in France. They really rarely mention local firms. But it's, of course, it's hard to directly test that. It's not the only thing that the jury was paying attention to, although, again, the jury, they were academics from other countries and they didn't have any intention to subsidize a specific sector. Yeah.
This might be the other robustness test where you looked at the scores. But one thing I was worried about is you think about the old National Science Foundation funding, Philippe's research when he was younger. When we applied for those things, you'd already had to have written half the paper and had the idea because you were going to be judged on it. And so whether you got the funding or not wasn't going to change the outcome of the research. And so in some sense they were selecting the things that were already going to be the winners. It wasn't the funding that did it, it was just entirely selection. And so that was the thing that was running through my head. So I thought your scores, you were going to use that, and that was going to be a central part of what you did. So I was surprised it was just in the robustness. And maybe it's the case that, when Philippe gets it, his stuff is great, and I don't get it, and my stuff wasn't very good. So even if you had the score, it's still selecting on the winners. But yeah, how do you think about that?
Reverse the net.
Yeah. So the scores, you mean, you were referring to?
Yeah, the grade, sorry.
The grade, yeah, okay. No, it's not the baseline, but it's something that we take very seriously. So the remaining of the presentation was about the channels, and here also maybe it's going back to your question. So what we find is that the channel that is the more active is the contracting channel. So we see that when laboratories got the funding, they took more and more private R&D projects that that are subcontracted to them. So it's not, the effect is of course driven by the pure knowledge, the increasing quality of the knowledge that they are creating, but maybe that takes longer. But the direct effect, the short-term effect is really through the fact that they now have more time and they can collaborate more with the private sector. They also organize, outreach and seminars with the private firms. But you're right, like the grades are very important. And the other thing that is actually going to matter is the fact that the policy was also designed with a way of being, fair for all the areas as much as possible and fair for all the scientific fields. So it's not like we are not going to give everything to the top laboratories that are in Paris and doing pharmaceutical. They try to give the money a bit to everyone. And so when we did a regression where we tried to explain the treatment using everything we could measure at the laboratory level, actually the grade that is measuring the spillovers doesn't matter so much. And that makes sense if you think that those jury they didn't really care about spillovers in the first place. They really care about academic excellence, and that's of course correlated with spillovers, but it explains much of the treatment. I have 1 minute, right? Okay. So let me just show you the main result on the channel. So basically what we did is that we measured, using all the data, everything we could in terms of direct connection between laboratories and firms. And what we find is that everything is activated following the treatment. So basically, there are going to be more PhD co-supervision. It's called the CIFRE program in France. So the PhD is doing the PhD in the firm instead of in the university. But it's still, supervised by the university. There's more academic spin-offs, so that's coming back to your question. There is a program called Jeune Entreprise Universitaire. Okay, so we saw, so those are basically firms that are jointly managed by an academic and a businessman, and there's more of them also. And there's of course more outsourcing R&D to public lab, and this is actually, when we look at the magnitude, this is the biggest effect that we have. So this is what we call the contracting channel in a sense. And the mobility channel is also active. So we do see that there is more transfer of senior academic and junior academic from the university to the private firms correlated with the treatment. And there is also more hiring of young PhD that are coming from the universities. Okay, so we can't really measure exactly whether or not those people are coming from the laboratory that received the treatment. We can only say that they are coming from the university. But still, this is evidence that there is some activation of all those channels that are the only way we could directly measure the spillovers and from which direction they are circulating. I think I'm out of time. I just wanted to mention very quickly why we see. This result was a bit surprising for us initially because everything that I know of that's been evaluating R&D program in France, they are basically saying that it doesn't work, and especially in terms of the R&D tax credit, which is 8 billion a year subsidies given to firms that are doing some R&D. And the characteristic of the R&D tax credit is that it's giving a fixed credit of 30% of your R&D expenditures as a tax credit, with some exception, but really for the very top R&D firms. And so if you look at the distribution of the sectors that are more impacted by the R&D tax credit, this is the blue bars, okay? And the blue bars, they're actually reflecting exactly, they are very correlated with the size of the sectors, okay? So the R&D tax credit is really not targeted. And to the contrary of the LabEx indirect subsidy, which is, we measure using our exposure, aggregating our exposure measure to measure some kind of subsidy, indirect subsidy, which rely heavily on some sectors like pharmaceutical and biotech, but also computer science. And here you see that this is of course not a direct proof, but it suggests that when you target a little more the R&D tax credit and R&D policy, you do see more effect than when you just give money to, regardless of the quality and the ability to generate innovation. Okay, so I think I'm done. Thank you very much.